This tutorial video is about the atom, specifically the structure of the atom. The atom is very small, and there are two major components to the atom. We have the nucleus, which is a small dot in my diagram in the center. And then outside of the nucleus, we have what we call this cloud of electrons, hence the electron cloud. So let's label those things. And we have the nucleus. And just to give you a perspective of the size of the nucleus in comparison to the whole atom, assume that we have AT&T Park be the size of an atom. We've magnified it to this huge AT&T Park. The nucleus would be the size of the end of your pencil's eraser in the middle of AT&T Park. So really, most of the atom is space. With that said, even though you have such a small nucleus, it actually has an interesting and very complex component to it. And that's what we'll be talking about next. So the atom is made up of different parts, and we call those subatomic particles. Now keep in mind, there are many subatomic particles. They're neutrinos, various other things, but we're going to be focusing mainly on three of the major particles. So we have protons, we have neutrons, and we have electrons. Now, as I said before, we have many other subatomic particles, and we're finding new ones every year, but these are the ones that seem to dictate how the atom is going to behave mainly. Now, we were talking about things being so small that, in fact, scientists have decided that they were going to give an atom a unique measurement. So they have determined that when we're dealing with atomic sizes and masses, we're actually going to call the mass, because it's so little, atomic mass units. And these units we're going to call AMU. Now, protons, remember, or if I should mention, are located in the nucleus. So if we go back here, let's add those. We have in the nucleus, excuse me.
Hello everyone, my name is Jaden Kurth, class of 20.
And as I mentioned before, the nucleus holds actually at least one atomic particle, that's the protons. So you can find those in the nucleus. And we have determined through experiments that it has one atomic mass unit. It's a very small mass, but we will say that it's one. Okay? Neutrons are also found in the nucleus, so let's include those as well. And they also have one atomic mass unit. So they are about the same mass as protons. And electrons are incredibly small, and they have a mass of 1/2000th of an AMU. And because it's so small, we actually just say it has 0 mass units. So we are saying that electrons do not have mass. That's not quite true, but the number is so small, it's not significant. And as you can imagine, the electron cloud holds the electrons. So, what is incredibly crucial when we are working with chemistry is that these protons, neutrons, and electrons have a charge. And they have determined that protons have a positive charge. And the way that I remember that is that protons start with a P and positive starts with a P. So we would say a +1 charge. Neutrons, on the other hand, sounds like neutral, and they are in fact neutral, and they have a 0 charge. And electrons, they have a negative charge, and each electron has one negative charge, just like each proton has one positive charge. So moving on, with the periodic table is a wealth of information, and I want to break down how to actually read the periodic table. So firstly, on the periodic table, you have a capital letter, either with a lowercase letter next to it, and that is what we call the chemical symbol. All right? And in this case, the chemical symbol for carbon is C. Often it will tell you the actual chemical name above. Next, you have a number towards the top, and we call this number the atomic number. So, what the atomic number means is it defines how many protons are in an atom. So, atomic number equals number of protons. The fascinating thing is that the number of protons determines what type of element it is. Anything that has 6 protons will always be carbon. It makes no difference how many neutrons it has or how many electrons, as long as it has 6 protons. If it has 7 protons, it's no longer carbon, it's now a new element. That new element is nitrogen. So the number of protons always determines what the element is. On the bottom over here, you have another number.
All parents and guardians should be making their way to the pavilion.
That number is called the atomic mass. So let's go back just a little bit to our table from before. So in the table, I told you that protons and neutrons have 1 atomic mass unit and electrons don't. So the atomic mass can be calculated like this. Atomic mass is the number of protons plus the number of neutrons plus the number of electrons. So let's take a look at this here. We know that for carbon, the atomic mass is 12. We'll go ahead and round it, 12 AMU. How do I know that? Because it states that below. So the next part of the mystery is I know that I have 6 protons. So 6 protons, and the 6 protons means that each proton is 1 atomic mass unit. That means I have a total of 6 AMU from the protons. At this point, I'm not told how many neutrons I have, but one thing I do know is that electrons have 0 mass, and so for that reason, they will always be 0 AMU because we don't consider them to have enough mass to count. So in that case, I need to determine what mass is missing. So I know that I need to get to 12. I have 6 AMU thanks to the protons. I need to get another 6 AMU so that 6 plus 6 can equal 12. Well, I know that every neutron is 1 AMU, and if I have a total of 6 AMU, that tells me I must have 6 neutrons. So the atomic mass is the only way that you can determine how many neutrons exist in your atom. So in this case, for carbon, we have 6 protons thanks to my atomic number. I know that I have 6 neutrons because I needed to find out the difference between 6 and 12 to determine the number of neutrons. There's another part that's very interesting with the periodic table. In a neutral atom, that means one that has no charge, it means that the pluses are canceled out by the minuses. So going back here, remember positive charge is the protons and negative charge is the electrons. Well, if I know that I have 6 protons, that means I have 6 positive charges. I just mentioned my atom is a 0 charge, so this has to equal 0, I can then figure out how many electrons I have. So 6 plus what equals 0? Well, you should intuitively say that it's -6. And so because each electron offers one negative charge, I know that I have 6 electrons. So we can say for a neutral atom that the protons equal the electrons. And again, that's going to be for a neutral atom. So now let's take a look at how we're going to draw something like this. All right? So firstly, let's just revisit this image. In the center, we were told we have protons and neutrons. So we're going to draw the protons as small circles with positive charges. And then I'm going to take the luxury of choosing another color, or perhaps I'll just color it in to show the neutrons. And in this case, for carbon, I know that I have the same number of neutrons as I do protons, and I squeeze them in between these protons. We'll talk about that a little bit later, okay? For the electrons then, I have the electron cloud, and I have, for this purpose here, for carbon, I'll have 6 electrons floating around. So this would be a representation of what carbon looks like. I drew 6 protons in the center. I drew 6 neutrons in the nucleus, and 6 electrons floating in the outside. Now, we can actually break that down even more to something that's called a Bohr diagram, all right? So a Bohr diagram is a simplified drawing of an atom. The way that we start is we start by giving the chemical symbol in the center. So I'm going to be working with helium. I look at the periodic table. Helium is He. I create a circle around helium, which will be my first electron shell. We're going to call that a shell. The first shell can only hold 2 electrons. And the reason it can only hold 2 electrons is that it's so small that only 2 electrons fit on there. So I have 1 electron in one shell and another electron over here. And it just so happens, just to break it down, remember that for helium, I have 2 protons, I have 2 neutrons, and I have 2 electrons. So it works out perfectly that I can fill those 2. If I only had 1 electron and 1 proton, I should only draw 1 electron on the outside. Let's try something else. How about trying phosphorus? So phosphorus has the chemical symbol of P. For phosphorus, let's take a look. Phosphorus has, thanks to my periodic table, 15 protons. It has 16 neutrons and 15 electrons. How do I know that it has 15 electrons? Remember, protons and electrons are the same. How do I know that it has 16 neutrons? Well, when I look at the atomic mass of phosphorus is 31. So I know that I have 15 protons. 15 plus what equals 31? It's 16. Now, we talked about the first shell. The first shell can only hold 2. So we're going to take 2 electrons in the first shell, but we have 15. Well, the second shell, and for these, it's going to be a little bit different later on, but for right now, we'll just keep it at this. Every shell, other than the first shell, has 8 electrons. So we have 2 electrons. That means we need to then fill the next shell, and that, remember, can only hold 8. So we'll go 1, 2, 3, 4, 5, 6, 7, and 8. So we now have 10 electrons, but we actually should have 15, so we create one more shell to then add the last 5 electrons. All right, so this is what a Bohr diagram for phosphorus would be. So just as a reminder, the first shell can hold only up to 2 because it's so small, and every subsequent shell can only hold up to 8. And so you want to make sure that you're placing all of your electrons in those shells, fill them first before moving on to the next shell. The last thing I want to be talking about is dot structures. For dot structures, they're even a more simplified version of drawing these here. And again, we'll start with helium. So helium, remember, has 2 electrons, 2 neutrons, and I'm sorry, I said 2 electrons, 2 protons, 2 neutrons, and 2 electrons. We do not concern ourselves about proton and neutrons again, but this time we only concern ourselves with the outer shell of helium. So I notice I only have one shell of helium. It's a single shell, and it has 2 electrons. So what I'm going to do is I'm going to draw 2 dots. I start on the top and then on the right first. So this is the dot structure of helium. Now let's try phosphorus. For phosphorus, I have 15 protons, I have 16 neutrons, and 15 electrons. Now keep in mind, we're only dealing with electrons on the outer shell, and I'm going to give a name to that outer shell. That is called the valence shell, and in the valence shell, you have valence electrons, and that is only the outer shell. So let's take a look at this valence shell, that's the outer shell, and count how many valence electrons we have. We have 1, 2, 3, 4, 5. So in that case, we need to draw 5 electrons for our dot structure. We start with the top, the right, the bottom, so we're at 1, 2, 3, 4 is to the left, and 5. So we first need to fill every region first before doubling up. This is phosphorus. Let's choose, for example, the chemical neon. Neon has 10 protons. It has 10 neutrons, and it has a total of 10 electrons. So how would we draw that? So the first thing I like to do is draw the Bohr diagram. So neon, remember the first shell can only hold 2, so now I have 2 of my 10, and the last shell can hold up to 8. 1, 2, 3, 4, 5, 6, 7, 8. So again, this is my valence shell, and I need to count how many valence electrons I have. So I'll start here. 1, 2, 3, 4, 5, 6, 7, 8. And I draw that on my dot diagram. 1, 2, 3, 4. Now I need to start doubling up. 5, 6, 7, 8. Couple things to note. Notice here they are side by side, but here they're drawn up and down. So on both the left and right side, you're going to draw them up and down on the top and bottom side by side.